Hello everyone, I welcome you all to Academy, where you can aim for higher goals, aware of those goals, and achieve them through Academy. Academy is for you to take the right decision, to move in the right direction, and to reach at the right destination. In today's lecture, we are going to learn how to design strut-based spherical periodic lattice structure, okay, in nTopology software. So here we are our motive is how can we create the spherical type of periodic lattice structures, and especially using strut unit cells, and finally we need to generate the spherical volume lattice. Okay, so let's start designing that. So first we can give the file name as like uh, like uh, strut based spherical periodic lattice structures. Okay, and we can add the description as the design of strut based spherical periodic lattice structures. Okay, and our section name is like a strut based spherical periodic lattice. Okay, so for this we first we need like a periodic lattice. So we can get it from lattice tab. There we have the lattice sub tab. From here we can get the periodic lattice. So let's select this. So earlier classes I have already explained how to use the rectangular volume lattice, cylindrical volume lattice, and spherical volume lattice. So if somebody wants to see, they can freely go and watch them. In today's lecture we are going to use the periodic lattice. Let's select this. So either we can get it from here, as I said, or you can directly search it, like suppose periodic lattice. Okay, here also you can search it. So in two ways you can search it. So let's delete one of them. Now within periodic lattice, so we clearly observe that we need to define three geometrical parameters. They are, one is a unit cell, second is cell map, and third one is unit cell parameter. So this parameter is especially depending on the type of unit cell we are going to use. In today's lecture we are especially focusing on the strut based unit cells. Okay, so let's select the unit cell type. So how can we get it? We can get it either from directly here by double clicking. So graph unit cell, as I said, there is no any specific term of strut. We are going to consider that as a graph unit cell. So either we can select it directly here, or we can select it from the lattices tab, and within that we have another tab that is called unit cells. From here also we can get it graph unit cell, or let's select this, or anyone, if somebody wants to select it, then type the unit cell. So we have various type of unit cells. Okay, so in today's lecture, as I said, we are focusing only on the graph unit cell. It is also known as either beam unit cell or strut unit cells. So let's select this. So like this, one can type the keyword which is already existed here. Okay, like this one can find it. So in three ways one can get it on the respective block. So let's delete one of them. Now here again, what do we observe? Here again we observe that we need to define two geometrical parameters within the graph unit cell. Okay, so let's define the unit cell type. What? So here if you expand this, so here various type of unit cells we already have within the nTopology software, so we can use any one of them as per our requirement. Okay, so it is a constraint. If somebody wants to design any novel unit cell, they can create it by using the custom unit cell option. We can get it from here only. Here there is one custom unit cell tab. So if somebody wants to design new unit cell as per their own requirement, they can freely use this tab and they can design it. So okay, so in today's lecture we are only focusing on the existed one, and how to generate the exactly spherical periodic lattice structure. So let's select the simple cubic. We have selected, this is our simple cubic unit cells. So where we have different vertical struts and horizontal struts, and here our local coordinate system as u, v, w, and it is within our bounding box. Okay, this is our unit cell with a size of I think 10 mm. Yeah, approximately it is 10 mm only. So I hope you got it till now. So now we are going to place our graph unit cell within the unit cell block, and let's minimize. Yeah, here again orientation in cube, as we have cubic unit cell, so there is no much effect, there is no any effect of orientation. So let's go with that as it is. Now we need cell map. In today's lecture we are going to select spherical cell map. So let's double click here. We can get it from here only, spherical cell map. Okay, either we can get it from here, as I said, if somebody wants to get it from here, cell map. So here let's find it for a spherical cell map here. Okay, or you can directly go to the lattice tab, and within that we have the cell maps. Here from here also one can get it. So both are same. So let's delete in one of them. And again, here we need to define some of the geometrical parameters. The first one is we need to like define the volume, type of volume we are going to use, and the radius of the particular unit cell, and the number of latitude count and longitude counts. And yeah, these are the major parameter we need to define. Okay, so let's define one by one. First, volume type. So as we are focusing on spherical volume, so let's select the volume. So for volume, I think once, okay, let's either we can get it, but still these things are not useful for it, I hope. So for that, uh, see here it is showing that pink color, but here they are showing in green color, so we need to get it from somewhere else. So let's go to the create tab, and within a primitive tab we have different type of volumes, 3D volumes, so we can select any one of them. So in today's lecture we are going to select the sphere. So we have selected this. Now its diameter is almost exactly equals to the cubic size. It means 10 mm only. So as we have a radius 5 mm, so let's, and it has one center point, and it has a radius of 5 mm. Now we can place this volume within the spherical cell map. Now we have defined the volume we have used, and now uh, yeah, we need to define the type of cell radius, what radius we have to give. Let's define it as a uh, 2 mm, and latitude counts we can give the 4, and longitude counts we can give the 4 only. Yeah, this is our spherical. Okay, now we need to our this simple cubic unit cell is going to incorporate within this boundary. Okay, boundary of the cell map. Now if somebody want, I will show you what is exactly linear it means after generation of that. So let's place this spherical cell map within the cell map tab. Now we have, yeah, we have defined two parameters. The third parameter is thickness. Earlier it was unit cell parameter 1. As I said, it depends, majorly depends on the type of unit cell we have used. As we use graph unit cell, so it has only one parameter, that is thickness. Thickness, okay. So now let's select change the thickness as a 0.3 mm, and wait for some time. Yeah, we have generated our spherical simple cubic spherical periodic lattice. Okay, this is our periodic lattices. It has three, no, it has how many latitudes? 1 2 3 4. How many latitudes we have given? 4, no? We have given 4 latitudes. Okay, 1 2 3. 1 2. Let's change this as a 3. Okay, 1 2 1 2 3. Yeah, 3 latitudes we have. This is our spherical simple cubic lattice. Now we can change it. If suppose somebody wants to give 8 and 8, and let's see what is going to happen. And we can give the cell radius as 1. This is our simple cubic spherical periodic lattice structures. Okay, and if somebody wants to change the unit cell, as I said, now we can freely change various type of unit cells. If somebody wants to change it to the body centered cubic, and then let's see what is going to happen and how it is going to look. Okay, see how beautiful it is, isn't it? Yeah. So this is how one can able to tune different geometrical parameters using the nTopology software. This is the advantage of it. So if somebody wants to change another unit cell such as face center cubic, they can do it. Now let's see how beautiful it is going to look like. See how really it is beautiful. Now if somebody wants to check its cross section view, look at this. This is the our, it's like a sunflower cross section. Okay, sunflower. Now let's see this, its cross section view at different planes. Yeah, this is how one can able to design the spherical, means strut based spherical lattices. So that's it for today. So in today's lecture we have learned how to design strut based spherical periodic lattices. For that we initially selected the periodic lattice from the lattice tab, and later that we have defined the type of unit cells as a graph unit cell, and the spherical map as a spherical map is cell map, and we given unit cell parameter as 0.3. So that's it for today, and I hope you understand this and you have learned something. Thank you. Keep learning.